Thank you very much, Luis. That was a very kind introduction, and most of it was true. But I know several of you in the room, but I don't know everybody. So I think I'll start by just before talking about this 100-year study panel that Luis mentioned. I'm going to just take a slide or two to introduce myself and some of the research that goes on in my lab. I know some of you are going to come on a lab tour tomorrow afternoon, so you'll get an opportunity to see some more details here. There's a bunch of different things that go on in my lab, but the sort of unifying question that ties them all together is the one here. It's to what degree can autonomous intelligent agents learn in the presence of teammates and or adversaries in real-time dynamic domains? So like many of you, I publish in the areas of autonomous agents, multi-agent systems, machine learning, especially reinforcement learning. I've been involved in reinforcement learning for many years when it wasn't so popular, and it's great to see that it's becoming very popular now, and especially robotics. And in my lab, there's both sort of fundamental, theoretical, and algorithmic contributions. But in a one-slide summary, it's a lot easier to show some of the applications that I've worked on. And so, as Luis said, I've been involved for many years in the annual robot soccer competitions. Many of you have seen this. These are the IBOs from more than 10 years ago. Working fully autonomously, we did win the Standard Platform League back in 2012. So this is, if you haven't seen RoboCup recently, these are using the Now robots. Ours are here. This was the finals of the 2012 competition. Ours are the ones with their hands sort of behind their back. We ended up winning that. When we came back, they lit the tower orange for us on the UT campus, which they usually only do when the football team wins. So we were very happy about that. And then this is back, like I said, 2012. Last year we finished second place in this league. It's gotten a lot harder. The field is bigger now. The ball is black and white. The goals are white instead of yellow. So the challenge keeps getting harder and harder every year. Here you see our robot going in on breakaway, and I'll let you see one goal just for the catharsis of it. There you go. I also did have a car in the DARPA Urban Challenge, so many of you are involved with or know about all the autonomous car coming. This is back in 2007. That car had no driver in it. This is one of the tasks in the Urban Challenge. It did 8 loops in about 20 minutes successfully. We've now retired that car because the car companies are putting huge amounts of money into that. But I still have an active research thread. I'm thinking from a multi-agent systems perspective, what will the world look like when all the cars on the road are autonomous? Will we need traffic signals and stop signs, or can we have something that looks more like this? In this video, what's going on is the cars that are white have already called ahead to an agent at the intersection, have reserved some space-time through the intersection. The ones that are yellow don't have a reservation yet, but as soon as they're white, they have a guaranteed path through the intersection. This we started working on back in 2003 when people looked at us like we were crazy when we said all the cars on the road would be autonomous someday. But this has led to lots of research on what happens if some of the cars are driven by people, some by autonomous cars. What happens if we scale this up to many different intersections throughout a city? There's lots of different research issues that this leads to. And the other application area, and you'll see this also if you come on the lab tour, we have a large project called the Building-Wide Intelligence Project, where we have robots like this one interacting in a social setting with people. More often than not, you don't have to ask us for a demo. This robot's just wandering through the hallways. In this particular video, this is collaborative work with my colleague Ray Mooney, who works on grounded language learning. The robot is learning through dialogue, learning to improve semantic understanding of human language. So over a week-long experiment, we showed that by learning from data where the robot is taking in utterances, having to ask questions for clarification, but then at the end understanding what the person wanted, and then getting those as training examples and learning a semantic parse of the language, the robot was, by the end of the week, able to be much more successful at understanding what people wanted and having shorter dialogues in the process. And so this was sort of one of the threads of research in our Building-Wide Intelligence project. Just briefly, because I know it's the theme of the workshop here, and you can find many more things on our page. But my most recent PhD student worked on something that we call multi-robot human guidance, and this is also sort of in a social robotic setting where the idea is that we have multiple robots in the environment, each doing some background task, but then this person came up and asked for guidance to my office or to some destination, and the robots collaborate with one another to try to be to guide the person there as quickly as possible, but without necessarily having to have one robot follow the person. So the robots can say, go in this direction, and then have another robot meet the person. At some points, the robot might need to lead the person like is shown here, but then they could say, go on and go to the next intersection, and the robots are trying to minimize their time away from the background task, while also minimizing the time it takes the person to successfully get to the destination. We model this as a Markov decision process, and are able to do planning in this kind of a setting. And just one more sort of peek into the kinds of things we're doing. We're doing also in the language theme. We have a robot with an arm playing an I Spy task. This was an HCAT paper last year, where a person is describing attributes of these objects, some of which are visually apparent, but some of which need multimodal interaction to understand. So if a person says, I see a heavy or a full container, the robot's going to need to pick it up and understand the proprioception or the weights on its joints, or maybe shake it to hear what sound it makes. And the robot is able to take all of these inputs to learn what people mean when they say tall, short, cylindrical, full, empty. And the robot gets to test its knowledge by having its own turn in this I Spy kind of interaction. And so these are all the kinds of things that we're doing within the Building-Wide Intelligence Project. You can find many other of our publications here. And I could have given this talk entirely on that, but I know there's a thread in this workshop on also sort of future implications of robotics and artificial intelligence. And so I wanted to really focus the bulk of this on what some of you may have seen, the AI 100 or 100-year study on artificial intelligence, which I had the privilege of being the study panel chair for. We had a study panel that was released at the beginning of September, and it got a lot of attention. And so I just want to tell you about some of the process that went into it, what this is, what the objectives are, and some of the findings we had, and then hopefully leave plenty of time for questions and discussion. So the goal of the 100-year study was endowed, or the origins, it was endowed by Eric Horvitz, who many of you know, and his wife Mary. Eric was one of the early employees of Microsoft. The goal is to support a longitudinal study of influences of AI advances on people and society, focusing on studies of the trends and potential disruptions that AI technologies can bring about, and also with a special focus on proactive efforts that can be taken to maximize the likelihood that the impacts of AI technologies will be more positive than negative in the long run. The roots were in the AAAI presidential panel at Asilomar. Many of us gathered, and when Eric was president of AAAI, at the place where the recombinant DNA folks created their Asilomar conference and their sort of manifesto of what kind of research should and should not be done in their community. And so there was sort of a symbolic reason to hold this kind of a discussion at Asilomar back then. And coming out of that was the sort of the germs of the idea for this 100-year study on AI. The structure of the study is that there is a standing committee. Barbara Gross is chair at Harvard, and many other people who you may know. And it's structured as follows. The standing committee every 5 years will invite a study panel, either a study panel chair, either one or two people. In this case, it was just one, just me. And then together, the study panel chair and the standing committee constitute a study panel, and basically are given a charge and need to go and produce some output in sort of a focused effort. And so our effort, for instance, I was the study panel chair for this panel. We created our output and then disbanded. I'm no longer a part of the AI 100 study. That the standing committee remains, and then presumably they'll invite a new study panel chair in 2020 and so on until at least 2115. So that's the longitudinal aspect of this. It's, there's many people writing about AI today, but the idea is that this is both that this is supposed to be an ongoing longitudinal study of artificial intelligence. The intended audiences are for AI researchers like ourselves, the general public, industry, and policymakers, which is sort of a challenge to try to balance all of those audiences in one endeavor. And the output is being archived at Stanford University. Formerly, the endowment was to Stanford to run this 100-year study. So the standing committee started by giving us a charge. and it was the following. It was to identify possible advances in artificial intelligence over the next 15 years and their potential influences on daily life, to specify some scientific, engineering, and legal efforts needed to realize these developments, and especially to consider actions that are needed to shape outcomes for societal good, deliberating on design, ethical, and policy challenges. And they gave us a focusing, sort of a focus, rather than saying AI, period. They said, focus for this study, and it may change for the future ones, on large urban regions, typical North American city, with the idea that there are many different influences of different AI technologies that all come together in a city. There's interdependencies and interactions among these AI technologies. But specifically, it also scopes out a few things. It scopes out military implications of artificial intelligence, which is a very interesting and topical issue as well, but that's sort of for another study. And it also scopes out sort of third world impacts and things that can happen in that kind of a setting. So it's sort of a typical, let's say, not necessarily North American, but first world urban setting. So when Barbara Gross approached me, I was very excited about this as an opportunity, but it was also something that gave me a lot of pause, because this is a huge challenge. She said, you have carte blanche with respect to format. This is the first one. You have no idea what the right thing is to do. Maybe write a report, maybe something else. You even have flexibility on the topic. There's the charge, but maybe it's not right. You can negotiate with us. What else? How do you want to change it before you invite your study panel? As you know, there's lots of ink being spilled about artificial intelligence right now, about industry progress. We knew there were some White House studies going on at the same time. There's a lot of press, a lot of fear-mongering from people outside of artificial intelligence getting a lot of press. And so, we had to come up with something. I had to think about, am I willing to lead this group in the context of all that's being written on these, future of AI, and take on the challenge of doing something that would both be topical now, and hopefully not only be topical, but be perceived as a balanced view on artificial intelligence, not from outsiders, but from sort of insiders, who are very close to the technology, that take into account the possibilities, and also the barriers to realizing those possibilities, and also realistic risks, and to comment on what is realistic to be worried about and what's unrealistic to be worried about. So that was sort of the current snapshot, but it also had to set a precedent for future studies over 100 years, right? No pressure there. And it should, and it had to be relevant over time. There was this, sort of this built-in audience that we assume 5 years from now, 10 years from now, 15 years from now, people will look back and judge, did we do a good job back in 2015 and 16? So it wasn't without a little bit of trepidation, but I decided to take this on. With the realization that it would be a lot of work, and it definitely was, but I'll go into that. The first task was to invite panelists. And so I talked to the study panel. We had to decide who should be on this panel, how big should it be, and we first decided we wanted to have a balance across AI areas, seniority, gender, to some extent geography, even though it was focused on North America. And so we came up with the following panel, with me as chair. I won't read down the names. You know many of these people. They're all our colleagues. About 2/3 are academics, professors at universities, but there's also representation from industry, from people who are interested in the economics of AI and technology, from the law or legal aspects of AI and technology, and also the social aspects. So I think we ended up with a very nice, broad panel. And so then it was up to me to sort of set the process. And it was, the first question that I posed to this panel was, what should the output be? Should it be a report? Should it be web pages, YouTube videos, some other form of multimedia? We had carte blanche on this, and again, this was going to set the precedent for 100 years. And there was a lot of groundswell against writing a report. Everyone said, there's so many reports out there, and if we write a report, whoever's going to read it, it's not going to have any impact. Let's do other things. And so, there was a lot of discussion about what other things. How could we do this? One interesting idea that was brought up was, for instance, could we set the precedent of taking pictures or videos that were possible to see in this year, in 2015, that would not have been possible to take in 2010. Like, for instance, I remember when the first time I saw a URL on a billboard, right? That was a picture you could take in 1995, I think, but not in 1990, right? So could we sort of, put together what could you see in 2015 that we wouldn't have seen in 2010, or what could you have seen, and see what else would come out of that. So we brainstormed a lot on this. I'll tell you where that went, but we also had to think about what topics. It was going to be North American cities, but what about North American cities? We're going to do everything. Just transportation because everyone's talking about that, not transportation because everybody's talking about that. Lots of discussions about what we would do. So we started out with a few monthly phone calls, I think 3 or 4, where we just came up with an outline for a background document. And the idea at this point was, we're going to have to do a document, but it'll just be a background document. It'll be where people go to get the additional details when they're watching the multimedia and looking at the videos and seeing all those pictures and all that. Because we need to have some source of information. So we finally agreed on that. Let's at least get a document. But the parts with real impact would come later, we imagined. So this led to, after we started in September, we had about 3 or 4 calls, we got an outline together, and then this is sort of where, I'm partly interested in telling you about the process, because we had sort of an interesting exercise here where we had an all-day in-person meeting in February at AAAI where most people came, most of the people from the panel, where we basically laid the groundwork in one day for all the writing of the report. We took all the topics from the background document, things like transportation, healthcare, home robotics, things like that. I put those on various tables around the room, and I told people, go to a table with a topic you're interested in and start writing. And we got an hour to do it. It was sort of this speed pressure writing, and then report back. And we did this for 3 or 4 different sessions. And by the end of the day, we had a Google Doc with sort of what ended up being the basis for the report. We then had months of back and forth, and I had the good fortune of bringing a professional writer on board to really polish this and try to make it accessible, which was the first kind of experience for me. I'd never worked with a professional writer, but this Kerry Tremaine, he was very talented, and helped us really make this accessible. And in the end, all the effort that went into this, it became clear that even though this was just going to be the background document, all the effort that was going into it, this was going to be our only output. We just weren't going to have the energy for anything else. And people ended up finally signing on to that, and so we really put all of our effort into making this document something that would talk to all of those various audiences. We then had a final in-person meeting to put the sort of call-outs in the margins, and we got lots of feedback. The study panel had 19 people, the standing committee had 7 people. You know what it's like to write with, edit with lots and lots of people. You can imagine what my inbox looked like. But in the end, it ended up with something I think we can be really proud of. And just to give you an outline, it's publicly available, but the structure of the document is that there's a preface for context. There's then a 1-page executive summary. So, nobody can tell me that they don't have time to read the executive summary. It's this and that. So, if you're curious, there you go. You can read a page and a quarter, and you get sort of the overview of what we're trying to say, followed by this sort of a hierarchical structure. So, a 5-page overview which expands on the executive summary, but is still an overview of the whole document. And then it dives into the report. And so what's in the body of the report, we have an introduction that defines AI and the current research trends. It divides up AI by domain. There's we identified 8 areas with likely urban impact by 2030, and I'll talk a little bit more about those. And for each of them, we decided we were going to include in the report both a look backwards, what's happened since 2000 to 2015, and then a look forwards 15 years. What do we predict will happen between 2015 and 2030? And in each one, try to identify the opportunities, barriers, and realistic risks. And also then the final section to come up with to survey the policy and legal issues, both their current status and recommendations for the future. And again, if you don't have time, you can, in this body, you can see lots of callouts in the margins that will give you the real, sort of high points of the report. So this is all to say, listen to me now, but really go read the report. It's all the feedback we've gotten, and it's really accessible and people have appreciated it both from within AI and the general public. But now to just tell you a little bit more about the content, the 8 areas that we identified that we wanted to focus on in the report, the ones in blue are the ones I'll talk a little bit about today in this talk. The rest I'll let you read about, but transportation, home service robots, healthcare, education, those 4, and entertainment, the last one, are sort of sectors. The other 3 are more sort of cross-cutting. And there's some sort of commonalities among them. Transportation and home service robots deal with hardware. Healthcare and education are more about partnering with people. And there's sort of an issue of trust that's needed, that's identified among these. The employment and workplace is all looking about societal futures. How are we going to deal with these, the impacts of technology in the workplace, and entertainment on interpersonal interaction. So what I'll talk about in the rest of my time is just a little bit about each of these. In transportation, it was sort of the least controversial of all of the topics we addressed. Everyone sort of sees it coming. There's lots being written about it. So that's sort of short term. Healthcare and public safety and security are more medium term. Employment and workplace we think of as more long term. In each case, there's sort of a progression from gathering data to building predictive models to building decision models. So we observed in the report that transportation, where there's both opportunities for prediction, like where is it going to be busy, and Google Maps kinds of things, and intervention, taking action, setting dynamic tolls, and having autonomous cars. We observed that this is really likely to be the first domain where the public is asked to trust artificial intelligence on a really large scale, like trust to the extent of getting in the car and your life is on the line. And that this, how this goes could really impact, or really set the stage for how future AI technologies are embraced by society. And so, you all know what some of the challenges are for autonomous vehicles and some of the AI technologies that go in there. I won't belabor. We observed that there's been surprising progress over the past 15 years in autonomous vehicles, both within the automotive industry and within sort of upstarts that weren't in the automotive industry before, in cars, and also more recently with drones, and so the technology is there, we know, but now they're having to grapple with a world full of people and human drivers and pedestrians and things. But we did predict that by 15 years, autonomous pickup and delivery would be common, and we'd also be seeing drones and possibly personal transport, air transportation and things like that. But certainly, autonomous cars are going to make huge changes, and I don't need to belabor that. I think that's many people have talked about that. Looking a little more medium term, in healthcare, again, there's opportunities for both prediction and intervention, where there's applications in clinical decision support, patient monitoring and coaching, management of healthcare systems, and the AI technologies can bring to bear. And by the way, just as an aside, I should say I'm being very careful, and we are very careful throughout the report, not to say AI will do X, but AI technologies will do X, to emphasize that artificial intelligence is not one thing that can just be sprinkled on anything to make it smarter, but that it's a collection of applications. In fact, I think we have our work. It's very hard to agree on a definition of AI, but our working definition, I can't read it here, but the first sentence was: artificial intelligence is a science and a set of computational technologies that are inspired by, but typically operate quite differently from, the ways people use their nervous systems and bodies to sense, learn, reason, and take action. You can imagine how long it took us to agree on that as a definition. Well, agree in quotes too, but in any case, so AI technologies, not AI, can provide predictive analytics for patients. So a doctor could ask, what are some of the commonalities for patients like mine, and also for individuals? What are the specific individuals out there who are experiencing the same symptoms or same experiences as I am? We noted that one of the important technical barriers is integrating human care and automatic reasoning, so that it's not, for this to really have automated reasoning, for this really to have to reach the potentials, it shouldn't be, or it can't be, an either or. Either you trust the artificial intelligence technology, or you trust the doctor. Really, we need to find a way for those to get the best, to have those be synergistic and greater than the sum of their parts, so that doctors and programs are sort of coming together and being integrated fully. So that's a technical barrier we call out. We also call out some social barriers like data privacy, trust of doctors, nurses, and patients. Well, trust on the part of doctors, nurses, and patients, which will be helped through transparency of decision-making models and the data that goes into them, and also removal of regulatory and commercial obstacles. And one of the quotes in the margins is AI-based applications could improve health outcomes for millions of people, but only if they gain the trust of doctors, nurses, and patients. Moving on to the other medium-term one, public safety and security. One of the problems we mentioned is, how do we tell which transactions are fraudulent, credit card frauds, compromised accounts? AI technologies could can use classification via machine learning based on data from records of fraudulent and legitimate transactions. We can get predictive models to identify the features of fraudulent transactions, decisions possibly at the level of autonomous termination of transactions when there's fraud. But we call out one of the risks here is encoding or maybe even magnifying human biases. And how can we build algorithms where there can be confidence that that only the factors that we want to go into these decisions are actually going into these decisions. We also mentioned in this public safety and security domain the opportunity for protecting infrastructure. Many of you know Milan Tambe from USC. He was on the study panel, and we call out some of the opportunities within computational game theory for intelligently randomizing inspections and patrols for unpredictability, and that's already happening in many different venues. And then finally, within in the longer term, with regards to employment and workplace, one of the quotes is, and I was actually, one of the quotes at the beginning is the current social safety net may need to evolve into better social services for everyone, such as healthcare and education, or a guaranteed basic income. Indeed, countries such as Switzerland and Finland have actively considered such measures. So we do observe that there is a chance of, a risk of widening the gap between the haves and the have-nots through some of the technologies. I was actually invited by the Prime Minister of Finland to come and give this talk about the AI 100 report because they're interested in sort of jump-starting a lot of efforts in these areas. We say that in one of the messages we do try to put out very clearly is that we believe that in the near term, AI technologies will replace more tasks than jobs. That it's not going to be wholesale jobs that are just vanishing. There might be some that's true of all technologies, but more that doctors aren't going to be replaced. Rather, the skills that doctors need to work with these programs are going to change over time. And we also note that they'll, as always, technologies, when they replace jobs, will also be creating new jobs, but it's a lot harder to imagine what types of jobs. It ought to lower, AI technologies ought to lower the cost of goods and services overall, making everyone effectively richer, which should be a good thing, but of course people focus the job loss is much more salient, and so that's going to be the focus for people for a short term. We did say that we think the fear of replacing all human jobs in one generation is overblown. That the gap between the rich and poor could grow, and that's something we need to deal with. And so we say it's not too soon for social debate on how the economic fruits of AI technology should be shared. Sort of tongue-in-cheek, we say as children in traditional societies support their aging parents, perhaps our artificially intelligent children should support us, the parents of their intelligence. But this is mainly to say that we need to think now about how we're going to react to this. And then just finally, that's sort of the technical part, and then dealing with the policy and legal issues, we call out a few problems. That AI could, the same one that I just mentioned, AI could widen existing inequalities if access is unfairly distributed. We also pointed out that as a society, we're underinvesting resources in research on the societal implications of AI technologies. There's a lot of resources being poured in to applications that are clearly going to make money or have a lot of potential to make money. But there's less investment right now on potential applications that can really help society. We also said that as AI applications engage in behavior that were done by a human would constitute a crime, courts will have to decide whom to hold accountable. People are already talking about that. And like other technologies, AI has the potential to be used for good or nefarious purposes. And we really it's important for us to try to maximize the chances that they'll be used more for good. And then finally, absent sufficient technical expertise, officials may refuse to permit a promising application or greenlight a sensitive application that has not been adequately vetted. This led to our first concrete recommendation, which was to define a path towards accruing technical expertise in AI at all levels of government, either by electing the right people or retraining or providing resources to people who have already been elected. And then the other recommendations that are prominent are removing the perceived and actual impediments to research on the fairness, security, privacy, and social impacts of AI systems, and to increase public and private funding for interdisciplinary studies of societal impacts of AI. So that's again, in summary, these are the main areas that we cover in the report. I just talked briefly about the first, the four of them over here, and also a little bit on the policy and legal issues. There's summarizing callouts in the margins. Some of my favorite are in green here. But I think in the interest of time, rather than reading through those, I read some of the callouts as we've gone. Maybe I'll flash them as we go, although there's sort of small font there. So I'll just encourage you to read it. And with that, thanks for your attention late in the day in this sort of hot room. But to the extent you have patience, I'll be more than happy to take questions.
Any questions?
Yeah.
Yeah. Thank you for the talk. It was very interesting. I would like to think about this idea that, for instance, you were talking about these automatic cars and substitutions regarding healthcare, for instance, with skills that medical staff has to have, for instance, to do a surgery, and other particular tasks that humans have to perform, and that are now being substituted by machines that do these tasks. And my question is more about, like, are we losing our skills biologically because we are giving these tasks to machines that can drive cars, and in the future we won't be able to do these things? So is that a concept maybe of human laziness, or it's something that perhaps we need to think that we need to upgrade our biological condition through these machines, or are the machines getting better and better and humans are getting weaker and weaker in the history of evolution?
No, it's a good point. It's a good question. I mean, I'm much better cooking in an oven than over an open fire. That's a skill I might have had, in old times. There's a lot. Technology has changed the tasks that we do over time. I think that's just the nature of technology. We have to decide which skills are important for us. Is it important that everybody knows how to drive a car, or is it okay if that's is that not a critical skill? This has come up already with autopilots, and do human pilots retain the ability to fly airplanes when most of the flying is done by autopilots? So it's a good point. That's not something we addressed explicitly in here, but I think it's very it is, if there are skills that we as a society decide that we want to make sure people maintain, then we need to actively take those steps. I mean, I think kids these days are probably less able to do long division by hand or multiplication by hand than we were when we were growing up, because they just don't have to do it anymore. And it's arguably it's not that. Some people would argue it's not that important that they know how to do that, because everybody's carrying around a device that can do that for you very well. Others would argue that's a really important basic skill, that if you're not able to do that, then you can't advance to higher concepts of mathematics. And so these are, I think, it's a good point, and it's something that we need to address on a sort of skill by skill basis. I don't think driving per se is one that is particularly important for everybody to have, any more than we don't think it's important that everybody knows how to fly a plane. Maybe it's not important that everybody knows how to drive a car, but I think there are some skills, and we'll need to make sure that those continue to be taught. Please.
is the report, I mean, when you say artificial intelligence, there's a bunch of techniques that are involved in that, the neural networks, remarkable processes, and those kind of things. Are you advocating greater use of those techniques, or is it something broader? Or
So we survey what are the current hot areas in artificial intelligence, and what are some of the areas that have become less less popular these days. But we're pretty non-committal about, we certainly are not saying everybody should be doing deep learning, or we're not saying everybody should be doing social robotics, or we're not being judgmental on what are the techniques that deserve more attention. We do call out a few that we think are ripe for progress over the next 15 years. So for instance, we mentioned that speech recognition of individual words and sentences is very strong right now, or getting stronger, but that we expect lots more development in sort of extended dialogue over the next 15 years. And this is an important area for research that hasn't really had impact yet in 2015, but may by 2030. And we also call out robotics and sort of manipulation tasks, and the ability to exist in a long-term autonomous setting in the sort of unconstrained, out of factories kind of world. So as one of the areas that's very ripe for progress. So those are areas that we call out, but we're not. It's not a prescription saying everybody should work on X or everybody should work on Y. We have some sort of predictions for where there's likely to be exciting developments over the next 15 years. Please.
So, historically, people have been pretty terrible about predicting the future of AI. Early researchers thought that language would be easy, but chess would be hard. MIT summer vision project looking for a grad student to solve the problem of computer vision in the summer. How do you feel about your odds of making good predictions?
Yeah, no, and that was part of that was the justification, or the motivation for part of the exercise, where we looked back to 2000 and said, what today would we have predicted, and what has been surprising between 2000 and 2015. We fully acknowledge in doing that we wouldn't have been able to predict everything in 2000 that happened in 2015, and so clearly we're not going to be able to predict everything that happens in 2030. We try not to be specific about this X will happen, or there'll be you won't find anything like 80% of the cars on the road will be autonomous, or anything like hard like that. It's more of the form. Here's the potential. Here's some potential we think that could happen in 15 years. Here are some of the barriers that if they're not cleared, they won't happen. But if they do, if we do clear those barriers, then there's a lot of exciting potential, and here are some of the risks. And so these aren't like vision is hard, vision is easy, language is hard. In chess, by the way, I think Newell and Simon thought it was a 10-year problem, and it turned out to be a 50-year problem. So I don't think chess was one where they thought it would be all that hard, or as hard as it was. But in any case, yeah, I mean, we have a dose of humility here, and we're not trying to say we can see the future any better than anybody else. What we are trying to say is this is the view of a fairly broad swath of people who are close to the technology as opposed to close to the science fiction. And we don't mention by name some of the people who are getting a lot of press for predictions that aren't close to the technology. But it's partly we're conscious of that as being some of the backdrop, at least today. Please.
So privacy is a major concern. Did you look into how AI kind of work into that?
Yeah, so privacy comes up in the sort of legal and policy section especially, and in the healthcare section, because that's one of the impediments is how we need there's potential for lots of predictions if all of the data is being interoperable, and you can learn from other people's experiences, but a barrier is how can we do that in a way that respects privacy and is secure. Technical challenges of can we obfuscate the data to try to, but still retain the core information. So yeah, we address that both in some of the the technical sections and in some of the policy aspects. But I agree, it's very important, and it's one of those. It's sort of a common barrier to that if we don't clear that hurdle, or if we don't figure out how to address it, then some of the potential won't be realized in the next few years.
What about public security? I'm thinking about the Dallas situation.
Yeah.
Did anything like that come up? Because that
Yep.
had not occurred then, right?
That's right. So we
And
talked
Patrick Lynn did a piece on that, commentary, so.
Yeah, so we have a whole section on public safety and security.
Right.
I didn't mention the part where we talk about predictive policing though, and that's another, you know, I talked about credit card fraud. Predictive policing is where, even more so, there's potential for biases being magnified, and, but there's already, I think we identified at least 4 police departments in the US right now that are already using AI technologies
Yeah.
for predictive policing to allocate the resources of where should they be patrolling more than others. We identified that, you know, number one, there's the risk of bias being magnified. Number two, if, you know, it also magnifies the sort of, you know, if people realize that the patrolling is happening here, then the crime may go over there, and, you know, so there's, but yes, the section on public safety and security does address more than what I had time to talk about today, and that's one of the issues for sure. Good point though. Yeah.
Yeah. Give us 2 comments. One is on the transparency of the AI technology. So we strongly requested the transparency of AI technology, or even the black box. We can use it. That's the first one. And the second one is even then, say we use the same algorithm or same neural network. If we use a different data set, the results should be changed. So this data set is also inside the AI technology or not?
Yeah, great points, both of them. So, with regards to transparency, and you know, people talk a lot about neural networks as an example of a non-transparent learning algorithm, and people are sort of wringing their hands and saying, "Oh, what should we do about this?" First of all, I think there's this goes to your second part of the question. The code of a neural network is very transparent, right? It's not very complicated. We can go in and it's you know, a few back propagations. It's not that many lines of code. It's not like we don't know what's happening when the neural network is being trained. So then the data is really what sort of causes the learning, and so, you know, I think if we are going to be transparent, we need to be both, you know, open to both what is the, you know, how does the algorithm work and what is the data set. So I think it is within AI. But, you know, there's sort of, transparency sometimes goes hand in hand with interpretability, right? People say, well, yes, the neural network is transparent because we know what the code is, we know what data went into it, but it's just a bunch of numbers and we can't really understand why it's making a decision. And then people say, oh, that's a horrible thing. My personal opinion, I don't think we say this explicitly in the report, but my personal opinion is that this is something that we shouldn't be as concerned about as people are, for the following reason. When I ask you to make a decision, or let's just use a judge for instance, a human judge makes a decision. There's a process by which they make that decision that's inside their brain, that's a lot of neurons firing, that it's completely uninterpretable to us, right? Separately, they can come up with an explanation for why they made that decision, but it's a different process that generates the explanation than generates the decision. And so in some sense, why should we hold our algorithms to a different standard? If we have a neural network that's making good decisions, it's not that hard to come up with tools to analyze, you know, what if we change the input this way, what would the neural network have said? And if we change the input that way, what would it have said? So we can come up with explanations that are maybe a different process than the neural network itself, and be, you know, sort of meeting the same standard that we hold our human counterparts to. And so, you know, I think the transparency aspect that I think is most important is when there are decisions that are sort of critical decisions, like the one that people bring up a lot is with autonomous cars, the trolley problem. You know, if a car has to veer one way or veer another way, you know, how should life be valued, and should it be more the passenger that's more valued or the pedestrians or whatever? Those kinds of decisions have never had to be made in code before. We have to be transparent about what those decisions are, and it shouldn't be the Google engineer in the back room who makes the decision. That it should be the engineers and we who sort of expose that decision and say, here's a choice that needs to be made, be transparent and open about that, and then let society, you know, go through the normal legal process or policy process of And maybe in one country they'll say in all situations the passenger's life should be valued highest. Or maybe in another country they'll say you need to judge based on the age of the person. Or I don't know. I mean, it should not be the people writing the algorithms who make that decision. The people writing those algorithms should be exposing the decisions, and to me that's the most important aspect of transparency. But yes, to the point of the data being a part of the algorithm and a part of the artificial intelligence, absolutely. And we also bring up in the report is that raises questions of, to what extent is data a public good? Should it be able to be protected within individual companies, and how much ownership of the data is by the companies or by the people who are doing the behaviors that are that are leading to that data? These are, again, policy and legal questions that probably shouldn't be answered by the algorithm developers, but need to be laid out there in a transparent way. Yes, please.
So I'm kind of interested at how, for this, at least the first part of this 100-year study, you seem to be focusing on the first 15 years going forward. And I guess my interest question stems from at what rate do you expect that to change?
Yeah.
And not only is it linear right now, you set up every 5 years you'll reevaluate, and then does it become exponential? Are we expect to see maybe step changes where we see large increments of change and then nothing for a bit, and then I'm just kind of
So you're asking about the focus of the study panels, or the focus of just development in artificial intelligence?
Development in artificial intelligence, and how the study is expected to change over these 100 years as artificial intelligence changes, and at some point does artificial intelligence become a feedback loop and therefore is part of the study itself?
Yeah, all good questions. So, I mean, my view of the progress in AI in general is despite the public perception that it's a series of these giant incremental steps and breakthroughs, that it's really been this long incremental community-wide effort with sort of gradual progress, and the algorithms like neural networks that have had reached landmarks in terms of performance are really have been developed 20-25 years ago, incrementally improved. We just got to a tipping point where there's the same old algorithms now with enough data and enough computation get these sort of landmarks that look like breakthroughs, but it's really a landmark. And that I expect that that's the way. Maybe there's slightly faster progress sometimes, slightly slower progress other times, based on how much resources is being poured in. But I think the reality from a technological perspective is much more sort of constant and gradual than it seems. With regards to the focus of the report over time, I have no idea. So I'm done. Did my job. It's up to the standing committee and the next study panel chair. We did give a postmortem and suggestions. People have suggested maybe they ought to take our document as a working document and have this was the 2015 snapshot and now edit it to say this is what it would have said in 2020. Maybe the charge will be something entirely different and focused on rural communities or military applications. 15 years, I think, was a little bit of a sweet spot, though. I wouldn't have wanted to go longer than that because, as was already commented, it's hard to predict it's hard to predict that far into the future. 15 years was sort of a period of time where all of us could remember back that far. And so we could sort of be realistic about what would happen in a 15-year time span, but it was far enough in the future that we can be futuristic about our thinking, but close enough that it's somewhat predictable. So I would be surprised if they changed drastically that 15-year period, but again, it's up to the standing committee in the next study.
So a lot of progress is the product of chaos, in my opinion. Can AI today, will AI in the future predict non-existing technology, for instance?
So are you saying, can somebody build an AI technology or an AI system to predict the future?
To predict non-existing technology.
technology.
Because I think that it's easy to say autonomous cars. If the technology exists today, where is it going to be in 15 years from now? But if you were talking about something like autonomous cars that doesn't exist today, are we ready for predicting the non-existing?
I mean, like you said, there's first a question of how predictable is it, right? I mean, there's a lot of chance events that can happen between now and 15 years from now that will dictate what actually happens. I could imagine it would be interesting to go back and and somehow encode the state of the art in technology at year X and the state of the art of technology in year, X plus 15 over the past 150 years, and throw that into a supervised learning algorithm and see, if we take a holdout set from the last 15 years, can it predict something worthwhile? That would be an interesting research project. I would personally be skeptical that that would work better than a typical person predicting the future. We've had some examples, very good examples, of people predicting the future quite well. One of my favorite authors or examples of that is an author named Edward Bellamy, who in the late 1800s predicted what the world would look like in 2000 and really got a lot of things right. At the time before radios had been even conceived, he was predicting that you would sort of open a tube in your home, and that would allow the sound of an orchestra playing in the middle of the city to come through that tube, and you'd hear that sound, and then you could close that tube. And sort of the concept of, he didn't get the technology right, but the idea that we'd be able to transmit sound over long distances, and some others. So there's a book that he wrote called Looking Backward that I recommend. There's of course lots of people who have predicted the future that have gotten it wrong. And I wouldn't. We had that. We were aware of that as we were doing this. That predicting the future is difficult. We did also people did suggest that we ought to look back to other times of disruptive technology, to the extent that today is a time when AI technologies are particularly disruptive.
Mm-hmm.
Maybe we should look back to what happened at the Industrial Revolution and what happened in other times when there were really large-scale changes. They didn't. None of them have led to all jobs going away. None of them have led to So what's the same and what's different about this from others? All good questions. We don't have all the answers though. Yeah.
So with all that collaboration, all that writing, did anything happen that you really didn't expect to happen? That came out of that process that was really unexpected?
The whole thing was unexpected. I had no idea how this was going to turn out when we started it. This was really a process of push and pull of 25 in the end. 19 were on a study panel, 7 from the standing committee, all sort of with opinions and long discussions, and I certainly could not have written this entire words in this report myself. This was the collective expertise of lots of people. So I was surprised in the sense that there was a lot of information that I learned while doing this. But I can't pick out one sort of nugget that's the biggest surprise or anything. We were not trying to be surprising. We were trying to be grounded and realistic. And in some sense, that was, if that's how we could be different in AI, where most people either consider AI is leading to a fully utopian society going to solve all the world problems, or a fully dystopian society going to destroy the world. That's where most of the writing about AI is. If we could be surprising by being realistic, then we figured we'd accomplished our goal.
I think we want to take one more question while you are tired, Peter. That's correct?
I can talk as long as you want, but
and I think people maybe they want to go out before the banquet. So let's take one more question, perhaps. Okay, Sabine.
So on the policy side, you mentioned that it would be helpful if we could educate policymakers on this topic. Do you have any ideas on that, and if they would be receptive?
Well, so at the same time as this 100-year study, Ed Felton was leading the White House reports and putting together a bunch of study panels. It was from the White House Office of Science and I can't remember the name, Office of Science and Technology Policy, I think, OSPP. And they put together some also highly publicized reports that talk about many of the same. Actually, when I went and talked in Finland, I compared our conclusions to their conclusions, and I have a slide on that. But there's a lot of things in common between the reports, and a lot of people actually. A lot of the people who are on my study panel also were in the workshops that went into those White House reports. I talked to Ed Felton afterwards, and about what are the likelihood that this would get taken up by policymakers. First of all, we know that the transition of administration probably made that less likely, unfortunately. His office, he said that it's quite likely that one of the targets for their report was the research arms of the Department of Defense and things like that. He said that it's already being paid attention to there, the kinds of things that we said in here and the kinds of things they said in their White House reports. how much knowledge transfer or uptake there is from what happened in the Obama administration to the Trump administration. He was a little bit pessimistic, I think, and not surprisingly. But in the long term, hopefully these kinds of lessons will be learned, and the more we can say it, and the more we can encourage people with technical expertise in artificial intelligence to get into policy-making positions and decision-making positions, the better off we'll all be, both as AI researchers and as just members of society, because of the, what I think the quote we said here is that, we don't want officials that refuse to permit a promising application because they're scared of self-driving cars, or green light a sensitive application that hasn't been adequately vetted. So, I think we need to encourage our students and people we know to get into those positions and provide this as resources. So, when I went and talked to, the Prime Minister of Finland's office, it was sort of serving in that role. And when people are inviting me to talk to policymakers, it's for the purpose of doing that. So, I'm finding people are receptive. Whether it'll make a difference, I can only hope.
Okay, well, thanks, speaker. Thank you.